Hello everyone, welcome back to week 5 of the different areas of AI. And for this week, we will be talking about large language model transformers. Now, I know we talked about transformers last week, but regarding the transformers, they were only on a basic AI level. Now, what are the differences between large language models transformers and transformers? Transformers use self attention to self learn, but it is in a much smaller scale and it is trained on limited data sizes or data sets rather. On the other hand, the large language models transformers are that it is trained on massive text data sets, and it is also fine tuned for conversational AI and reasoning AI. And it's also designed for text generation, text summarization, and dialogue. So the topics I wanted to cover for this week is memory versus generalization, modifying facts in a large language model using transformers, and what the difference between large language model transformers AI versus a regular transformer AI in terms of performance wise, and we'll go more in depth there. So, the first topic, memory versus generalization. So, what is memory versus generalization? Well, generalization is to apply what the AI has already learned to new and unseen data, while memory is being able to specifically recall a certain information that the AI has already learned during its training. And memory in AI models, especially in large language transformers, is about storing and retrieving very specific facts or information from the model's vast parameter space, which basically means that it's trying to recall very specific information by pinpointing what it needs to recall. This means that if the model was trained on a particular piece of knowledge, it should be able to recall it accurately when it is prompted to do so. But the issue with this is that memory is not structured like a database. It is more distributed across the model's weight, and it's influenced by the training data. On the other hand, generalization is the ability of an AI to extend and apply knowledge to unseen or slightly different scenarios. And a shorter way to say it is basically it's applying what it knows to something that it doesn't know. And instead of just memorizing specific facts, the AI that generalizes, well, can basically do really well pattern recognitions and infer answers, even if it hasn't encountered the exact question it was asked before. So, for example, if a large language model has read thousands of historical documents, it might be able to answer a question about ancient civilizations it has never explicitly seen, simply by connecting key concepts and patterns from the relating texts in the historical documents. However, if the AI leans too much on that set of data, it might start to generate incorrect information, and we usually call that hallucinations. The next topic I wanted to discuss about is modifying an LLM using transformers. So we know that once an AI learns something, it's pretty much going to stick with the AI. But let's say it learned some wrong information and you wanted to switch that. Since modifying large language models are relatively complex, it's hard to update the model without affecting the entire AI itself. And unlike traditional databases where you can update a record directly, large language models, they encode information across billions of neural networks and in a highly distributed manner. One common way to change a fact that is already presented in the AI is by fine-tuning the large language model on a new data set with the corrected information. This is so that it overrides the current data set and instead just proceeds to use the data set that's right for it. But this process involves training the model on a relatively small but very carefully curated data set that contains the updated knowledge. And while the fine-tuning of aspect of it is rather effective, it requires a significant amount of computational power, and it can alter related information, leading to catastrophic forgetting, where the model forgets the previously learned facts. So if you want to try to update your AI, you have to be very wary about where and how you're going to be updating it. And it'll cost a significant amount of power in where it tries its best to take the updated information, but it ends up being overridden with unnecessary information, causing the AI to get explicitly right but wrong answers. So the third and final topic I wanted to talk about today was the different AIs that either use large language model transformers or regular transformers. And regular transformers are used in models that focus on specific tasks rather than a general purpose AI. They're typically much smaller, but they're more faster and optimized for well-defined problems. An example of this is Google's Vision Transformers, or VITs for short. And it is used in image recognition and computer vision tasks, while obviously for large language model transformers we have the GPT-4 or ChatGPT, in which case it's used for basically what everyone uses it for, whether it be text generation, reasoning, and including coding. So I wanted to also talk about the differences between them. While GPT-4 specializes in text-based tasks, VITS specializes in image-based tasks, meaning that GPT-4 cannot recognize images and URLs, while VITS can easily identify what the given image is and basically tell the user what it is. And the GPT-4 uses a decoder-only transformer, while VITS only uses an encoder-only transformer. So that's what I wanted to talk about today. Thank you for watching, and I hope you have a great day. Goodbye.